Welcome to this video on radar level transmitters, 20 most common interview questions and answers. In this session, we'll explore everything you need to know about radar level transmitters. Whether you're preparing for an interview, refreshing your technical knowledge, or working as a process or instrumentation engineer, this video will give you clear and comprehensive answers to the most frequently asked questions. So let's get started and make sure you're fully prepared to face your next interview with confidence. What is a radar level transmitter and how does it work? A radar level transmitter is a non-contact level measurement device that uses microwave signals, radar waves, to determine the distance between the transmitter and the surface of a material, liquid or solid. It works on the time-of-flight principle. The radar emits a signal, it reflects off the material's surface, and the device calculates level based on the time taken for the signal to return. What are the types of radar level transmitters? Non-contact, free space, radar, uses electromagnetic waves transmitted via an antenna. Best for liquids, corrosive media, and extreme conditions. Guided wave radar, uses a probe or waveguide to direct radar pulses. Suitable for both liquids and solids, with higher accuracy in turbulent or foamy conditions. What is the difference between free space radar and guided wave radar? Free space radar, signal propagates freely, suitable for long ranges and harsh conditions, but can be affected by dust, foam, or vapor. Guided wave radar, GWR signal travels along a probe, less affected by disturbances, provides better accuracy in turbulent or foamy conditions. 4. What frequency ranges are used in radar transmitters? 6 GHz, older technology, larger antenna, sensitive to obstructions. 26 GHz, standard in many industries, good balance of performance and cost. 80 GHz, FMCW radar, high accuracy, narrow beam angle, minimal interference, ideal for tall or narrow tanks. What are the advantages of radar level transmitters? Non-contact, no moving parts, low maintenance. Works under extreme pressure and temperature. Not affected by changes in density, viscosity, or dielectric constant. High accuracy, plus or minus 2 mm or better. Suitable for aggressive, corrosive, or hazardous environments. What are the limitations of radar level transmitters? Accuracy may be affected by heavy foam, dust, or turbulence. Dielectric constant of material must be sufficiently high for reliable reflection. Incorrect installation, obstructions, angled surfaces may cause false echoes. Guided wave radars may face coating buildup on probes. What is the minimum dielectric constant required for radar level measurement? Typically, epsilon r greater than or equal to 1.4 to 1.6 is required. Below this, reflection strength is too weak, and measurement may be unreliable. What installation considerations are important for radar level transmitters? Avoid installation near tank walls, nozzles, agitators, or ladders to prevent false echoes. Ensure vertical alignment to avoid signal reflection errors. For guided wave radar, probe must reach sufficiently into the medium. For conical bottom tanks, install at the center for better accuracy. How do radar transmitters handle foam or vapor? Foam, guided wave radar performs better than free space radar. Vapor/steam, high frequency, 80 GHz, radars are less affected by vapor condensation. Special condensation-resistant antennas may be used. What is the principal difference between radar and ultrasonic level transmitters? Radar uses microwave signals, not affected by temperature, pressure, vapor, or dust. Ultrasonic uses sound waves, accuracy is affected by temperature, pressure, and vapor conditions. What is the effect of temperature and pressure on radar level transmitters? Radar is generally immune to temperature and pressure changes, unlike ultrasonic or DP transmitters. However, extreme conditions may require high-pressure rated antennas and temperature compensation. What is blocking distance in radar transmitters? Blocking distance, or dead zone, is the minimum distance below the antenna within which measurement is unreliable. The radar cannot detect levels within this zone. Typically ranges 0.2 to 0.5 m for high-frequency radars. Larger for older, low-frequency models. What is false echo suppression? False echo suppression is a configuration function that allows the transmitter to ignore reflections from tank walls, agitators, or nozzles. This ensures accurate detection of the true material level. What accuracy can be expected from radar-level transmitters? Free space radar, plus or minus 3 to 5 mm typical. Guided wave radar, plus or minus 2 mm or better. High frequency, 80 GHz plus or minus 1 mm achievable in many cases. Where are radar-level transmitters commonly used? Oil and gas storage tanks, crude, refined products. Chemical reactors and vessels, corrosive or pressurized. Water and wastewater tanks. Solid silos, powders, grains, cement, coal. LNG/LPG cryogenic tanks. What are typical output signals from radar transmitters? Analog, 4 to 20 milliamperes with HART. Digital, Modbus, Profibus, Foundation Field Bus, or Ethernet-based protocols. Some transmitters provide relay/alarm contacts. What is time of flight versus FMCW in radar measurement? Time of flight measures time taken for pulse to travel and return. Frequency-modulated continuous wave measures frequency difference between transmitted and received signal, providing higher accuracy and better resolution in challenging conditions. How does radar-level measurement handle solids compared to liquids? Solids, irregular surfaces, dust, and angle of repose can cause scattering and weak reflections. High-frequency radars, 80 GHz, with narrow beam angles are preferred. Liquids, more reliable, smooth reflective surface gives strong echoes. What are common troubleshooting issues in radar-level transmitters? Erratic readings caused by foam, turbulence, false echoes. No signal load dielectric constant, improper installation, damaged antenna. Drifting values condensation, coating on probe, for GWR. Noise caused by agitators, splashing liquid, or buildup. Why are radar transmitters preferred over DP transmitters in modern plants? DP transmitters require impulse lines that may clog or freeze. Radar provides direct level measurement without fluid columns. More reliable in extreme temperature/pressure conditions. Lower maintenance and calibration needs.